Let's look at mean, median, mode, and range. Now, all four of these are just words that we can use to describe data. Now, the three that all start with M, mean, median, and mode, all describe what I think of as kind of the middle of the data. They describe what's sort of normal, okay? And the range is a little bit different. It describes how spread out the data is. So you've probably seen mean before. It's the exact same thing as average, just a different word to describe the same thing. So it's quite simple to calculate. You just add the scores together and divide by how many there are. The median, one important tip is that you have to line the scores up from smallest to largest before you start. So if they're all jumbled up, start by organising them from smallest to largest, and then the median is just the score that's in the middle. I remember that median is middle to remind me how these two are different. Now, if there isn't a middle one, and there won't be if you've got an even number of scores, then you have to take the average of the two scores that are closest to the middle. So we'll have a look at that in a moment. The mode is just the most common score. So just have a look at what there is most of. So it's possible that sometimes there isn't a mode because perhaps there's no score that's any more popular or common than the others, or there could be more than one because there might be two or even three or more scores that are equally common. So that can happen. And then the range is just how spread out the data is. So what is the highest score? What's the lowest score? And you just do the highest one minus the lowest one. That gives you the range. So let's see how this works. If I ask you guys how many pets you have, and I just ask 9 people to tell me how many pets they've got, I've got some sample data here, some numbers to work with. So let's work out the mean number of pets here. Now, first we better count out how many people answered the survey. 1, 2, 3, 4, 5, 6, 7, 8, 9 people. So if we add these up, we've got 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 divided by 9, because the sum of the scores is 15 and there's 9 of them. Now, if you write it down as 15 knights, looks a little bit confusing, doesn't it, as a number? How many pets is that? Now, if you put that in your calculator, it will simplify the fraction for you, or you can do it in your head if you're good at doing those. Put in 15 knights, hit the equals button, and it will tell you it's 5/3. If you want it as a mixed numeral, hit Shift and then the SD button, 1 2/3. Now that looks like a much more reasonable sort of answer. 1 2/3. Now clearly you can't have 1 2/3 pets, but that's the average for this group of people. Okay, the median. Well, we have to line the scores up, don't we? So make sure you count them all. I like to cross them off as I use them and as I rewrite them down. I've got 2 zeros, 1 and 1, 2, 2, 2, and then there's a 3 and a 4. And it's not a bad idea even just to double check you've got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, we've got them. Now, finding the middle one, if there's not too many of them, the simplest way is just to count in from the edges and just taking your time to make sure you've got the middle one. Looks like this one is the middle one. And I can tell because there's 4 scores below it and 4 scores above it. So the median is 2. That's easy. Mode, what is the most common score? Well, this is easier to spot once you've got them in order because you can easily see how many there are of each one. There's 2 zeros, 2 ones, but 3 people said they had 2 pets. So that's the most common answer, isn't it? So the mode is 2. And the range is the biggest score, 4, minus the smallest score, 0. So that's 4. Nice and simple. Now, before we leave it there, let's just consider what would have happened if we'd had an even number of scores, because working out the median would have been a little bit different. Well, if we had an extra score on the end here, let's just say we had another person with 4 pets. Then as we count in from the edges, we would have got to a halfway point being here, where there's 5 scores below that line and 5 scores above it. So then you'd say, all right, what's halfway between this score and this score? Now, halfway between 2 and 2 is just 2. But if these were 2 different numbers, you'd just find the halfway point between them. And that's just averaging them. So that's just adding them together and dividing by 2. Now, it's important to understand why we would want to use the median as a measure of what's normal rather than the mean. Well, sometimes when you have a score that's really, really big compared to the others or really, really small compared to the others, it really sways the mean a lot. And so that can give you a really unrealistic idea of what's normal. let me give you an example. Let's just say this last person that came in here to the class said, hang on, I've got a lot of pets. Maybe they've got a farm and they've said, I've got 325 pets. They've counted all the cows on their farm. And everyone's rolled their eyes and gone, they're not what we meant. But anyway, that's their score. Now, will the median change? No, it won't. We've still got 10 scores here, and when we count in from the edges, the middle point is still 2. But the mean is going to change a lot. Let's look at what the mean would be. 325 plus 4, 329, 332, 336, 338, 340. So we've got 340 divided by 10. The mean is now 34. And yet most of the class would be saying 34 pets. That's not like a normal amount of pets for us to have. Most people only have a small number of pets, and this kid has a huge number of them. So a measure of the mean pets, in this case, being 34, wouldn't be very helpful for describing how many pets everyone in our class has. So the time that you'll see median used instead of mean is where you've got large or small scores like that. We call them outliers. They're just unusual scores. And if you've got an outlier, it won't really affect the median too much, but it would affect the mean a lot. So one place you'll see it, often in the news, you'll hear them talking about the median house price or perhaps a median salary. So if you want to know what's a normal sort of salary for an Australian to have or a normal house price, then using mean won't be very effective because most people live in fairly moderate houses, but a very small number of people live in mansions, and they would blow the mean up to be an exaggeratedly high figure. Similarly, most people earn a moderate sort of salary, but a very small percentage of people have no money at all, and a very small percentage of people have billions of dollars. And so again, they'd be like the kid with all of those pets, making the mean look artificially not very normal. So the median you'll see a lot more often like that because it doesn't get swayed so much by outliers. Now, it's probably easiest to calculate mean, median, mode, and range when you've got a nice list of scores. But don't forget that if your data is arranged in a stem and leaf plot or a dot plot, you can rearrange it as a list so that then it's easier to calculate all of those 4 things. So here, don't forget that we just look at the key and work out what 2 line 2 means. That means 22. So that means 0 line 2 would just be 2. And then here we've got numbers from 10 to 20. So this is 10, 11, 13. And here, these are all numbers in the 20s. So 22, 23, 27, and 29. Now that we've got a list like that, it's much easier to calculate our parameters. When we're finding the median, you'll also see that because we've worked our way along the rows, they're already in order. So finding the median is nice and simple. It's going to be here, halfway between 13 and 22. How do you do the average of 13 and 22? Add them together and divide by 2. So here we would have 35 divided by 2, which is 17 and a half. If your data is in a dot plot, same thing. This just means that some people were surveyed. Perhaps they were asked how many brothers and sisters they had or something like that. One person said they had none. 3 people said they had 1. One person said they had 2. There was a couple of 3s, and there was a 4. So again, I can see at a glance that the mode is the most common score, 1, and the median score would be halfway between 1 and 2, that's 1.5. And the average, I need to just add them all up and divide by 1, 2, 3, 4, 5, 6, 7, 8. So I've got 3, 4, 5, 6, 7, 8, 9, 10, 11, 15 divided by 8 would be the mean. And the range, 4 minus 0, 4. Now I've got a formula for the mean. The mean equals the sum of all of the scores divided by how many there are. So in some questions, it's not too difficult to do a bit of problem solving. If you know the mean and you know one of these things, you can figure out the other one using this rule. For example, if a bunch of scores add up to 240 and the mean is 10, how many scores were there? Well, if we sub those numbers into this equation, the mean we know is 10. The sum of the scores is 240, and the thing we don't know is how many scores there were. Let's just write n for that number of scores, where you can switch these two here. and say that n is equal to 240 divided by 10. And that makes sense because if two numbers are multiplied together to make a bigger number, then when you divide the big number by one of its factors, you get the other. And it doesn't matter which factor you divide by, you'll always get the other one. So the number of scores must have been 24. Now check and see if that makes sense. If you had 24 scores, you'd be doing 240 divided by 24, and that would give you 10. So sure enough, it works out. In this second example, the average of three numbers is 6. Two of the scores are 1 and 9. What is the third score? Well, if you know that the average of the numbers is 6, that goes here, and that there were 3 scores, then you've got something divided by 3 is 6. You guys know your times tables. 18 divided by 3 is 6, right? So the scores must have added up to 18. So we've already got a 1 and a 9. That's 10. So the other score must have been 8. So that 10 plus 8 would give us the 18. Check that it works out by plugging it back into the formula. And that's how you solve problems like that.